In this video, I will be inputting a 170 volt peak signal sinusoidal into this 10-to-1 step-down transformer. On the output side, I will be getting a full wave rectification. I will be inputting a 170 volt peak signal on the primary winding of the transformer. On the secondary winding, I will be getting a 17 volt peak signal. The diodes I will be using is the 1N4007 diode. Now I will be finding a peak voltage on the output. Now, on the secondary winding, I have a 17 volt peak signal. At this voltage and that resistance, the voltage across the diodes will be 0.72 volts. On the positive half cycle, the diodes D1 and D3 will conduct. D1 will have a voltage at 17 volts peak on secondary. Will have a voltage of 0.720 volts. On diode 3, the voltage will also be 0.72 volts. So V peak is a 17 volt peak signal minus the 2 times 0.720 volts. That gives you a peak signal of 15.56 volts. Now this voltage will be for the first half cycle. On the negative half cycle, the diodes D2 and D4 will conduct. These voltages is also 0.720 volts. And on D4, 0.720 volts, which means that the peak voltage on the negative alternation will also be 15.56 volts. Now I'll find the average voltage. V average out equals 2 times 15.56 volts divided by pi. and that equals an average voltage of 9.90 volts. Now the volts RMS equals the peak voltage of 15.56 volts over the square root of 2. And that equals 11.00 volts. Now, on the positive alternation, the diodes D1 and D3 conduct. On the negative alternation, the diodes D2 and D4 conduct. Now D1 and D3 is in series with the 1K ohm resistor, and D2 and D4 will also be in series with the 1K ohm resistor. This is why when you find the peak voltages, or when you find the peak voltage, you have to add the voltage drops across the diodes. You add D1 and D3 on the positive alternation, and then you add a D2 and D4 on the negative alternation. This brings me to the end of the video. Like and share the video, and thanks for your attention.